everyone. Welcome to the Tech Talk podcast show, where we bring together leading minds within our community to share their expertise and insights for the benefit of our tough members and others. My name is Periyasamy, instrumentation engineer working in Kuwait Oil Company. Our topic today is one that is at the heart of the modern industry, transforming oil and gas projects with modern engineering tools. This is a field undergoing rapid transformation over the years, driven by many software tools that enhances engineering activity from project feasibility study to commissioning and handover of the plant. To help us navigate this interesting topic, we are honored to have our guest, Mr. Rajendra Kannan. He doesn't need much introduction as he is well known among the engineering professionals in Kuwait. He is having long association with Tef and he has served as a president in Tef 2023 committee. When it comes his professional career, he completed mechanical engineering from Bharatiyar University and he is renowned expert having more than 25 years of experience in engineering field and presently working as section head for mechanical department in Gulfspeed Contracting Company Kuwait. We are truly honored to have him with us today and I forward to hearing his valuable insights on how modern engineering tools are shaping the future of oil and gas sector. Welcome, sir.
Good evening. I would like to thank Tamil Nadu Engineers Forum TEF 2025 committee for this wonderful Tech Talk opportunity on the topic of transforming oil and gas projects with modern engineering tools. I would like to hear from Mr. Periyasamy for this today's session.
Let us begin today's discussion with very simple question. What does project engineering mean in oil and gas projects?
Let me explain in a brief way, since different discipline engineers are viewing this Tech Talk. Project engineering design. When you take project engineering and design, it has different phases like feasibility, then design and detail engineering. And then we have final dossier and the handover stage. Let me explain with one small project. Then maybe it will be very clear for. Let us consider building a home as a project. So building a home is everyone's dream. Like when you start the project, you have to start the feasibility. Feasibility in the sense whether home it is affordable, how many people going to live, which location we are planning, what all the amenities are good. So these are all the things we will study. Based on that, we will decide whether we will build a home. This stage for the project, you can consider as a feasibility. When from feasibility to feed, we have to move. Feed is nothing but what is decided, we are bringing into a paper form, like preparation of drawings, specifications, what kind of specification we are going to use on home, like what tiles, granite or marbles, what is our windows, how many bedrooms, what is our corridor. These are all things we will bring it as a drawing and with a detailed specification. This is we can consider as a feed. When once the feed is over, then you will go for EPC base. EPC is like you will find a contractor. So we have to give the drawings and specification to contractor to bid for his cost, and based on the cost you will select the contractor. Then he will do the real engineering. Real engineering is detail engineering. He will be doing the foundation design, structure design, the wall location, window location, door location. These are all the things. So this way they will build the with a coordinated way, with a good engineering. Once the engineering is over, project is completed, then handover. During handover, they will be giving all the final drawings and details. So this is the simplest way we can understand the engineering stages like feasibility, feed, design and detail engineering, and handover. The similar thing applicable for oil and gas. When we take oil and gas project, this involves same like when design concept finalization, then calculations, that feasibility with a lot of simulations and other things. We will be finalizing the feasibility things. Once feasibility is over, then feed, then we will go for EPC and detail engineering, then final handover. The engineering team will be taking care from start of the project from concept to handover. The main tasks are design and detail, design, concept, calculations, technical coordination, scheduling, budgeting, vendor engineering, then risk and safety management, then document reporting. So these are all the thing project engineering considered.
Yeah, that is very interesting. So there are many software tools are used in oil and gas projects. Can you explain why these project engineering tools are critical in managing oil and gas projects?
Critical in managing oil projects. So let me explain in this way. When you take oil and gas project, that itself a critical one because as you everyone aware, oil and gas projects are unique and very complex in nature and very time lapse project. From the feasibility to end product, it will take too much time. And then scale and risk profile, dealing hydrocarbon is very risky. It has environmental and spillage issues. So a lot of things are involved. When you take a small project also which involves multidisciplinary interactions like different departments like process, instrument, electrical, civil. When the scale of the project, if you say offshore platforms, refineries, greenfield gathering centers, then pipelines, drilling rigs. So the nature of this scale is very high, very apart from that complex interfaces. Each and every project will have interface with different vendors and contractors, different regulatory bodies. So when apart from that there is environmental risk, safety hazard, then like conditions. So these are all the things very complex system. And when you go for complex system, the thing we cannot do all these manual calculation and manual things. So definitely we need a very computer-based software tools to carry out the project engineering. So considering the criticality of oil and gas project, definitely the engineering tools plays a major vital role for the engineering purpose.
Yes, since you have told there are many complexities in handling these oil and gas projects. Now, what are the main challenges in oil and gas and the software tools will help to address those challenges?
Okay, you see complexity. When you take a project, all not same. There is a process plant on 50,000 barrel with gas handling or a crude distillation unit. So these are all different in process, these things. So the main challenges these tools helps is like right from the beginning, from the feasibility stage to end, like simulation, very complicated process simulation we can do with these kind of tools. Then sizing, equipment sizing, very optimum sizing. Then failure analysis, when you do the piping configuration, what all the failures will happen. When you do the design, what all the failures will happen. So failure analysis. Then optimum sizing and economical design. Then coordination with multidiscipline. That is the biggest challenge oil and gas project. So civil, mechanical, electrical, and important. Then cost overruns, like there is a delay, there is a change in spec, scope change, which leads to cost and time. So these are all the main challenges. Apart from, we can get very good BOQs, drawings, fabrication drawings. Then we can kill safety environmental risks by using the proper tools. Then climatic and harsh environment. When you lay subsea piping, when you do rest area, cross country pipeline, the design conditions are there. So tools are utilized to handle these critical situations.
Thank you for your detailed explanation. Now, can you tell us what are the softwares or tools most commonly used in oil and gas projects?
When you say tools in oil and gas, this one, I can. There are some tools very quickly coming into my mind, and very renowned tools, and people are very often using throughout the oil field in Middle East. When you take process simulation for the simulating the process, high we are using. Apart from that, pipeline design, cross-country pipeline design, pipe phase, Olga, pipenet, these softwares used. Then when you come for detail engineering tools, Aviva E3D, it's integrated tool behind the creation, mechanical modeling, then electrical instrumentation design, everything we can do it with E3D. Same like Hexagon Smart Plant 3D is there. This also integrated tool. Then we have very specific analysis softwares like pipeline stress analysis. We have CSA tool. When you go for a pressure vessel design, ASME section 8 division 1 and 2 pressure vessel design, we have PVL light compress. Then we have tank software, storage tank software. We have a tank. These are the products from very often used in oil and gas.
Yeah. You talked about various softwares used in like discipline-wise process, all those things. So whether you are using any software for planning, cost estimation, and the safety studies?
Yeah. See, actually, when you consider project engineering, apart from designing, the same importance is required for scheduling, then safety studies, cost estimate and all. We are using like Primavera, Microsoft project very extensively we are using. These are the well-known software everywhere people are using. Apart from that, for cost estimate, we have Cleopatra Enterprise, then Aspen Capital Cost Estimator, AS, then Ecosys people are using. Then when you consider risk and safety risk and complaint, there are a huge number of softwares available. Even DNV is then developed a lot of softwares. But in general, people are using for HAZAP, QRA modeling, cloud modeling, and all people are using. For HAZAP, we are using PHA Pro, HAZAP Manager. Then DNV Synergy Life for incident and risk management. So these are the software utilized for safety studies. And one thing I like to emphasize, like Mr. Kadisham asked, document management system also very important. We are people are using different project, different tools used, but normally we are using Aconics, then Procore, then SharePoint. The SharePoint and Aconics are all very elaborate tools. You can control the entire project documentation right from feed to end product from all over the world. We can handle it.
So in each project, there will be thousands of documents to be, shared with client. So how you manage the revisions? It is the software will handle
Yes.
those revisions.
Yes, see this Aconic SharePoint and all, the hierarchy, responsibilities, review cycle, everything will be defined, and it will handle revision cycle also. The moment it is submitted, it will transfer to concerned party, and comments will be read back. So things once on track, you can track the document status, approval cycle, what all the area is, everything we can take. This software management, this document management tools really taking care of these functions.
So maybe a new information for many. I am also surprised to hear this many softwares are available and they are used in the oil and gas projects. Since you talked about 3D modeling and all the softwares, can you tell us what role does 3D modeling and simulation softwares like Aviva, Smart Plant, AutoCAD play in oil and gas projects execution?
Okay, let me go with simulation first because simulation is the start point of every project. So the simulation related software should be used right from being like a early feasibility to feed itself. The simulation software is not. Simulation is nothing but optimize and validate the entire process by using a software tool. When you build a plant with a two-phase separation, oil with the gas, so for the capacity, what all the separation system required, what all the separators, like transfer lines, pumps, desalters, then effluent system, everything will be defined using simulation softwares. Like if you take a crude distillation unit, everything will be done using a process simulation software. Mainly these simulation softwares, we can model the fluid flow, all the heat exchanges will be taken care, then chemical reactions will be simulated. Apart from that, we can define the batch limit packages so that the inlet and outlet conditions will be taken from the simulation softwares. Then mainly this roll-up simulation software also involved in finalizing the equipment sizings, the right specification, right sizing, because this is very much important. It will control the cost and it will avoid oversized and undersized pumps, compressor, heat exchangers, mainly heat exchanger and all, very important to size. These are the simulation software used to. Then dynamic behavior of fluids. These are the things simulation. I will explain it a small example. You wanted to transfer two-phase crude line from one point to another point with a 100 kilometer distance with certain pressure and capacity. Crude with gas mixer, which will have a two-phase flow. The velocity between gas and crude is different. There is a possibility of slug formation and surge. So these are all the things by manually we cannot identify. We can identify, but these are all very tedious, this one. And there is a possibility of wax formation, hydrate formation. These are all things, everything will be accurately modeled and predicted by simulation software. So with this simulation software, the base work will be completed. So this is a very key for all the engineering, the simulation softwares and this hydraulic softwares. Then when we go for 3D modeling, this output will be converted as a physical format with a 3D model, then drawings, BOQs, for the completion of project. When you take a 3D model software, it will give very accurate design visualization, class detection, then material takeoff, and it will facilitate the procurement activities. Then construction planning, we can do it. 3D modeling software, then safety, accessibility, the assessment, like all different stakeholders we can bring into a table and we can review the model. So operators point of view, maintenance point of view, we can finalize the layout. Then collaboration across the teams, like where to put a pump by electrical team, how to lay the cable, what are the cable routes, what is the feature expansion. Same like instrumentation, what are the junction boxes, where we can put the junction boxes, then cabling, everything, trace, routing, everything we can finalize with the 3D model software. So nowadays, without 3D modeling, doing complicated or oil and gas, even small to medium to large scale projects also very difficult. So where simulation and 3D softwares are extensively used in oil and gas projects.
Yeah. So basically, these softwares will help minimize the design change, field changes like process request and field change notifications. It will miss those things during the execution.
Yes, absolutely.
Yeah. So you talked about various software tools used. Can you explain how are these tools applied during different phases of projects, like feed, detail engineering, procurement?
See, in the right beginning, I have just given a glance about what is feasibility, feed, and detail engineering. Mainly, when you take software tools which are suited from feasibility stage onwards, then the same software will be utilized till the end of the project. These softwares are really required in but the extent of software, the extent of detail what we are deriving from the software and tools is will differentiate with stage to stage. When you take feed, mostly we will be using simulation softwares, then P&AD tools, then apart from that, cost estimation software we are using it. When it goes to EPC stage, mainly detail engineering tools like 3D modeling, then isometric section, then construction softwares like spool preparation, fabrication, detailing softwares we will be using it. Then like framework or project planning we are using at the EPC stage. But when you go for commissioning stage, there are a lot of commissioning tools are there that also equally important to utilize when that WinPCS, COMOS, and janitor in control. These are all the common tools people are using in commissioning. These tools are very much required to track the punch list, then testing and inspection checklist, report submission, document handover, everything is taken care. So each stage unique software tools are used to write them the feasibility to cut out.
That's excellent. And each oil and gas projects having many interfaces with each discipline, like mechanical, electrical, instrumentation, all those things. And whether you are using any software tool for interfacing, like integrated tools.
Okay, actually, we can say integration in two ways. There is a tool, integrated tool, which integrate with multi-discipline engineer. If you take a smart plant 3D shoot, Aviva PDMC 3D, these are the integrated tool. We can make tool and you can make a 3D modeling. From 3D modeling, you can make a instrumentation design, data sheet generation, spec generation. Same like a electrical design, cable routing, everything you can do with the same integrated tool. When you take collaborated tool, collaborated tools are mostly used for the overall project. So engineering part we will use engineering tool like integrated tool. Apart from this Aviva E3D, we can collaborate with the SAP system, which will take care of entire procurement. Then we have a project planning, Primavera integration. So there is a spec change, it will intimate to procurement. And there is a scope change, isometric construction, isometric change, it will inform to Primavera so that subcontractors will be notified. So this collaborative tool. So based on the scale of the project and necessity of the project, you can use integrated tool or a collaborative tool. So this way the engineering tools are helping for the frequent error-free project completion.
So basically, now it will help to minimize the gap between the interface between the projects.
Yes.
So it's wonderful actually. So based on your experience, can you share an example where the right tool significantly improved the project outcome?
Right. See, actually, when you use a proper engineering tool, you can do the proper design with optimized cost in all the stages. But when you ask like completion of the project, the coordination collaborative tools are required. We can go with some example. There was a situation with a high capital cost project. The project engineering done in good way, construction is also done good way. But the end, they were struggling to commission the project to clear all the punch lists because everything managed with manually and inconsistent documentation, then a lot of loop checks completed, but test reports are not properly transferred. So finally, the entire system come into mess up condition. So in that case, there is a tool suggested for WinPCS for mainly commissioning. The expected delay was 6 months. Then after replacing this WinPCS, everything brought into on track, and within 40 days, the entire system is commissioned. This had a very good tracking system like punch list tracking and manual handover, all everything digital handovers are there, and loop checks, other thing all completed. So this is one quick example. When you use like a very good integrated tool, you can avoid a lot of errors, things when some model is completed, isometric from ISO to spool, so numbering, everything, welding, everything without any issue we can complete.
Basically, we can overcome from project delays.
Yeah.
Okay, and
Manual
many
errors.
manual errors.
Errors.
Yeah. That is great to hear. As we near the end of today's session, I would like to ask a question that I believe in on everyone's mind. How do you see project engineering evolving in the coming years, especially with the rise of artificial intelligence and digital technologies?
When you say artificial intelligence taking over everywhere, everyone knows artificial intelligence taking over everywhere, and it is closely, very effectively utilized, and things are coming up in very rapid way. But time being, engineering industry, not much utilization, only dashboard preparation and some presentation kind of things we were using. But what I can say my view soon the artificial intelligence very much working together with the human, like human and computer. We have to do code design. Mainly where it will take is integrated system, like all the discipline integration. Artificial intelligence will play a major role. Then AI augmented engineering. Actually, when you finalize the layout, from the layout, the detailing AI will take care based on the previous experience. When you have a company having 10, 15 facility, all data are available in the system, and they want to make a new facility, even it can optimize the layout for the company, and it can create the drawings for the modeling for the company, so that everything will be in the optimized way. The AI augmented system will be there. Then AI will predict all the risks. Like when you utilize AI in the construction project, it can predict the construction consecutively risk and the cost to overrun issues and the delay issues. It will track it. Earlier, what we were doing by experience, we can predict. Very experience and theoretical way only will work. So you have to, the project is started, the control wall will take a long lead item. So you try to order early. These are all the things by experience people will know, and they will explain to the contractor or co-workers. But now AI will, once the project planning and other things are finalized, AI will tell what all the things to be taken care, what all the cut-off date, everything it will predict. Then what I mainly predict is this modularization and standardization will play a major role. Now there is a very prone tailor-made plug-and-play system is available with a capacity of some 10 tons or 20 tons. Then you want to go with 30-ton plant. It will optimize all the things, including layout, everything. So this design help it to do. So once layout is finished and the modeling is to be created, if you use AI, it will reduce lot of manpower. So automatic generation and other things will be very much implemented in engineering. But what we predict, this will take. This will not take much time. It will come into
Very soon
use
it will
very
implement.
soon.
Yeah.
Expected. Things are happening. A lot of conferences are going on, seminars and other things. We are also seeing things are in a lot of AI agents. A lot of things are going in engineering sector.
As you rightly said, I think AI will play major role in engineering,
Yes.
handling these softwares also. Yeah. So there are, these refineries are, constructed maybe, 40 years, 50 years before, and maybe in the 20 years before also. These, these are the old, based on without any softwares, these plants are constructed. And in what way these softwares will help to, make upgrade these plants? So your role, your suggestion on this?
This is really challenging task, as you asked. See, in earlier stage when the plant was built during the year 1980s, and all, we will be having manual drafting and 2D softwares only. Once the plants are installed, doing a small modification like a brownfield modification, it is a very challenging task, and increasing the capacity or adding a new equipment in the running plant. For this, we are suggesting, and we always utilize laser scanning technology. There are like a very renowned companies like Leica, Jet and F. They have very good laser scanning cameras that can be installed, and the entire model will be captured as a cloud model. From the cloud model, we can generate intelligent 3D model. That intelligent 3D model is utilized for modification and modification jobs. Apart from that, this entire intelligence system can be utilized for owners' reference purpose, and they can transfer this to and also from this model they can digitize all their outputs like layout drawings, everything, PNDs, everything they can digitalize, they can keep it in their central arch.
So you talked about each discipline having different softwares. Just I want to know how this each softwares will interact each other, and what is the interoperability of the softwares used in the when we come to the execution of the projects.
Yes. Actually, earlier stage in the year 2000 range, we have similar issues. We have similar issues. At the time, different companies developing their own individual softwares, and everything will be working in silos. So when you do one work, the other software will not. We cannot transfer the data to other softwares. Even you transfer also, it will not be 100%. So this was a challenge. But now, when we select the software, the right tool, this is a major criteria. So every company now they are very much available with interacting with all other softwares. I will explain with a small example. When you do 3D modeling, the entire route will be model, but you want to do the stress analysis for that line. I cannot again model on CSET software. So if something in Aviva, I have E3D, if I built a model, Aviva is different company, but this stress analysis software from Hexagon, this is different company. So I can get output file. That output file I can load it in CSET software so that all the data will be transferred here. Same like if it's a smart plant, the output file will be modeled here. Then I can utilize for analysis. So now these things, I can say it's not 100% solved, but we have solutions. Same like from the 3D model, we can generate isometric. These isometrics will be given to dot IDF files. So these files will be utilized by spool preparation softwares, Spoolgen or Proman and all. So they can generate spools from this software. So now also like different companies will have different software owner operators. Maybe owner operator will be having E3D in all their works, and the contractor, EPC contractor will use smart plan. So now things are coming together. People can give intractable formats they can supply to the company.
So one last question. For example, if any young engineer or fresh graduate, he wants to pursue his career in engineering design, what softwares he has to study and what knowledge he should have?
Actually, I'm from Chennai, and now Tamil Nadu is the biggest engineering hub, the evolving biggest engineering, and there is a lot of major oil and gas key players are having offices in India. Take when you asked what software we have to study, this depends on the discipline. And also, each discipline having a different software. Okay, when you take mechanical, you can go for analysis software. Who has very good engineering background with interest in analyzing skill, they can go for set to PBL8, tank design software, and they can go. Those project aligned mindset, they can go for 3D modeling software. When say case mechanical engineer, they can rightly apply application for ETAP. Plus, if you take chemical engineer, they can go happen ICS, Unisim, and lot of companies, training centers available in India, all over India, and Tamil Nadu. They can, during the curriculum itself, they can go and study for 1 month, 2 month course. And when they find time, they can go for industrial visit, and they can match both together. They can look for opportunities.
Okay. Thank you very much. Thank you for sharing your knowledge, and thank you for valuable time. thoughts about modern engineering tools and oil and gas industries. Thank you.
I also really happy to associate with Engineer Berisami. He is a very well-known providing as professional in Kuwait. Thank you for your time. Thank you.
Thanks. On behalf of the 2025 committee, I would like to request Mr. Suresh Anand to hand over the moment to Mr. Rajendra Kannan.
Thank you.